morph, right? So they do all of that. And then some of the activities will involve equipment like what I mentioned. There are some equipment like this. This is a sensor. This is a sensor, right? You might have seen this times. And there is a device, lab test. This is from Vernier, right?
Sensor for what?
For force. This is for force.
Force. Yes.
This one is for force. Yeah. There are some 30 odd sensors. For instance, this is magnetic field sensor. There is a temperature sensor. There is a moisture, pH, carbon dioxide, lots of things. Photo gates. So there are many. So what I can do is I can plug any one of these like this, and it will identify that this is a force sensor and give the value in Newton. Yeah.
Newton.
Right? So I can do that. So if let's say I have two of those, some simple experiments. Another force sensor if you have. Another force sensor. If I have another force sensor, I'll take two of them, plug both of them, and then do an experiment on Newton's third law. Right? It's as simple, because what I can then do is take this, plug the other one as well, right? So it recognizes both of them. So there are two, right? There are two.
You can compare.
Yeah, what I can do is now I can do this. There is an action, there is a reaction. There is a thrust and an anti-thrust. I'll pull it and see the readings. One is stuck. One got stuck somewhere. Hold on.
I think it's stuck as 12.
Yeah.
More than 12.
This is getting into, I think there is some setting or something. Yes. Let's not pull too much. See, that's the problem. It's not good.
So your company also...
See, if I do just this much, it's almost equal. Right? Then I'll say I will not pull, only Vasu you pull. Even then it is the same. Right? So that is if I pull or not. So I'm trying to explain the Newton's third law. Just giving an example of how it could be used. Similarly, you can use this for friction. Pull a wooden block on different surfaces and see what's the friction. Right? Or I can use thermocouple and measure the temperature. Or I can use, there is an activity for magnetic field. So there is a magnet in between and then you measure the magnetic field around the magnet. That's a classic experiment children do around magnetism. Right? So we use some of these devices. Now the beauty is, when we do this, right, there is another port here. From this USB port, you connect to the computer. And that is integrated with our platform, what we saw now. Just now, that platform integrated with that. So essentially, an activity is launched like this. A teacher assigns an activity for a group of children, 40 children, let's say, or 30, 20 children. They come into the lab. They log in to our platform. The moment they log in, they get that screen on which that activity which the teacher scheduled comes up with a launch button. The child launches that activity. The step-by-step procedures are laid out. Right? The steps could be that you take a 1 year lab quest and choose a force sensor. Plug in the force sensor, could be a step. They actually do it. Then they will have to write down something, let us say, record your observation. There is a text box there for recording their observation. Now they say, actually grab the data. Okay? You will have to suppose you are pulling a wooden block on glass. Right? So you do that. While you do that, here you have the option of taking a measurements here where, you actually do this. So you do this. Hold on. Just pull, whatever. See, you can see that graph. The two almost equal all the time. Right? So you can do that and stop. Right? Now you did this. Now you want this to be moved to your platform under my login. Because I captured this data. I'll say, okay, I'll select whatever. I have selected this data. When I get into the platform, I can show it to you maybe later. I'll say get data. Whatever I captured here. Because you have integrated this device into a platform, this data is pushed into the platform, into that activity against that child's name.
I think I can see the next generation of this. You're gonna connect to Wi-Fi, and then you have to log in.
Absolutely.
And then when just you finish, you just submit, and then it goes
You
to
are
the
absolutely right, Dr. Chetty. And each one will carry a device like that. So you need not have to actually, you will have a device of your own.
Yeah.
You don't have to go there, log in, nothing. USB into my device. Done. Data is here. Go. Do whatever you want.
Another thing that you might have the only interface, but every child got device, and then you connect to your this is the display device and the controller, and then once you got it, you submit to the
That's how it is.
yeah.
Technology-wise, platform-wise, we are already ready for that. We are already there. It's only that
Okay, let's set up a school in Thailand.
Set up a solution,
Yeah.
not a skill. We provide you solution, not skill, right?
These are some interesting ones,
No,
This is
together we have to do it.
These are on motion, right?
Gyros, no? Yeah.
Right? So this means this is rolling down, right? So the slope is down, correct? It's rolling down. This should fall off.
Yeah.
Magic.
Magic.
Went back. Why? Because the center of gravity is up. So actually what they do is, after this, they insert a pencil like this, and they have a hard surface here, and actually show that the center of gravity which was here keeps moving down. So it actually follows the center of gravity, not the plane. Right? Another thing, what is this image? Beautiful. What is this?
Look through that.
Look at this.
You see
You see the image of the face.
Okay, the person there.
Yeah.
Similarly, this one,
Face. What is it?
It all,
Where it come from?
yeah, anamorphic or something like that they call it.
Magic.
Yeah. And again, this one.
Oh, the lady.
Those kind of things. This is around when for an activity around light. So deformation of light and all of that. Yeah, the reflection of light and all of that. So they say, deformation. What? And we have another one here. So this is a typical one. So they say, okay, for the children, right? All these make it exciting for the children. So they see from here. So you can see. You will be seeing something. Can you see my hand?
Yeah.
You can see. Now I'll do this. I'll block the view. Can you see now?
No.
How is that? Even when I block this. Right? For us we know that we have done something here. But for children it will be very interesting. You can see it from here. Even if I blocked it out, blocked your way, but still can see. How? Then we'll ask them to explore. So then they come and open the lid here. Which one of these is a lid. It's a lid. Then they say, okay, here is the magic. Here is the magic. There was a mirror here, there is another mirror here. Then the concept of periscope. How does a periscope work? And all of that. Right? So that's it. So all of these were constructed by this team here. They do. They construct everything.
So that's the reason why they use this,
Yeah, funnels.
It's just a funnel. Right? If you see there's a bottom.
Yeah, this one is
you do it then.
this is for us. This little toddler. They actually do this, they take it out in the screen and actually pump it with water. They'll be filling it with about water, and they pump air into this from a distance, and when it fills with water actually gets launched and go as high as our building. It actually went. What did
We have
I
the rocket.
Yeah, that's what it is.
station.
Yeah. So it goes up to about 30-35 feet. 100 feet away. And then it's not just that, you'll also have to have the fins properly, otherwise it won't. So there is a test for that. So it's pretty, lot of chemistry related experiments as well. They have actually removed all of that. They have a lot of chemicals and all of that. And we use again, like how the 1 year vital orders is integrated with our platform. We also integrated the microscope. Microscopes are also integrated. For instance, these are digital. So basically, it's a digital microscope. So is it connected? Sure. So you can actually see that image here. And from our platform, again, one button click, you can capture this image, whatever you are seeing, into the platform against that activity for the child. I haven't set it properly. Just twist it out. So some of these activities, what we have, need not necessarily have any technology involved at all sometimes. So that's how we, technology only is a resource. So for instance, this one is around town planning. Of course, here they use a little bit, they use Google Earth and all of that. They use Google Earth, but generally what they do is they are planning a town. They are given a plain land and told what resources are available where, what is the altitude, and they will plan the whole town with those, these are apartments, these are industrial blocks and all of that. Right? They actually do the town planning with some basic rules to be followed. Right? How much should be the green belt, how much should be whatever. So that is it. Likewise, there are lots of activities into lots of events. Right? Now I talked about projects. Right? There are different kinds of projects for a long duration, 2 to 3 months kind of projects. One of the projects is around the weather. We have a proper weather station on top which receives data. It's available all the time. Temperature, moisture, humidity, rainfall, everything is captured. Children of grade 6 in our school have a weather and climate as a subject in science. Weather and climate is a subject, right? Not a subject, sorry, a chapter. A full chapter in science. Grade 6 mathematics has data handling. They are introduced to data handling, right? Using those two as cues, they do a project. Every day, the entire year, right? Twice a week, they come 3 days during the day, morning, afternoon and evening, and record temperature, humidity and rainfall. Right? They record the data for the entire year. In the school calendar, we have taken data handling and weather and climate towards the end of the year. So the teachers don't teach them; they give a project. Whatever is contained in the chapters will be deduced via the data they collected during the year. Seasons is something. What happens in a rainy season? Right? In India, we have 4 seasons, right? 3 seasons: summer, winter, rainy season. Right? It's a rainy season. What happens? Rain. Okay, then from your data you have gathered, now you have plotted that data. Now you tell me when is the rainy season. Right? You will not actually tell them it rains when it is rainy season. They will actually see from the data and rains. Okay? And seasons is one. And then what is the effect of rainfall on humidity? From the data you tell me what happens to humidity when there is rainfall. Obviously they see humidity increasing when there is rainfall. Similarly, what happens to temperature when there is rainfall? Temperature decreases when there is rainfall. This kind of analysis is done via the data they gather, and that's a project, right? That is one thing. The other is we use a platform which we have built called Project Maker, right? We will see that in detail maybe later because I cannot just explain it like that. It's a very interesting concept. I think we should do at least 1 or 2 such projects in Thailand. Very exciting, very nice. We will see that there.
Okay,
Right? That's
we
the
appoint
second.
you principal of
Ah,
Excel School, Thailand.
and there is another kind of project which we are doing, which is physical kits. This is one example we have come up with, which we have called the Great Plant Hunt. This we did in collaboration with the Royal Botanical Gardens, Kew Gardens, UK.
Two gardens in UK.
Two garden, yes.
ಇದು
ಎತ್ಕೊಳ್ಳ
ಇದಕ್ಕೆ ಒಂದು ಕಳೆದ
ಇದನ್ನೇ ಕೆಳಗಡೆ ತಗೊಂಡು ಕೆಳಗಡೆ ತಗೊಂಡ್ರೆ
there should be a ring here, which is not right. So this is what we built in collaboration with Kew Gardens. This again is to commemorate Darwin's 200th birth anniversary, Charles Darwin. It's called the Great Plant Hunt. It's around biodiversity, about plant taxonomy, about conservation of flora. Right? Because it's botanical gardens, they are focusing on that. This is supposed to be a chest, a treasure chest carried by Darwin when he went around the world on HMS Beagle. When he went to Brazil, Australia, Galapagos Islands and all of that. So those stickers are there just to give that feel of Darwin's treasure chest. What it contains is, it contains lots of resources for teachers to conduct a project in their schools for grade 1 to 7. Grades 1 to 7, right? For instance, where's the teacher's manual? Teacher's manual is in here. Just pick up a teacher's manual. Somebody has taken it to. Okay, there's a teacher's manual, a big one, which gives a lot of suggestions on the kinds of activities they should be performing. Right? There is, for instance, one activity where they use a resource like this. This is called the identikit. Right? This is grade 4 or 5. They do this. They go out wherever they find a little flora, and they will have to spot a plant. These are commonly available plants in this region. Chocolate weed, or a common mucus which we call as tumbe vida, and there is something which is holy basil, which is tulsi, which is again. Yeah, you have it too, right? Yeah. This is the holy basil. So these are commonly found plants. So children go with this identikit, a group of about 20 children, and they look for these plants in the nearby vicinity. Why we get them to do this? Take a handbook, binder, it's a big binder. Right. What happens is they may find the plant in a particular stage of its life cycle. Yeah. Right. Let's say they found it when it's a young plant. Then the teacher, when they find that plant, the teacher calls everybody together. Everybody is in a group now and say, okay, this is the plant we found. This is like this. This is called holy basil. You know, it gives all the other common names in local languages, scientific names, flowering season, fruiting season. Gives a description of that. Where can it be found? Some users, some fun facts, how is the seed dispersed, how does it germinate, all of that data, and then she says, okay, now you tell me the plant is like this. Okay, then it becomes like this, when the seeds form. So she introduced to the plant like this. So this, basically, you're doing it in a very different way, introducing them to plant life cycle and things like that. For instance, small children, grade 1 children, when they go out for we call them as thinking walks, right? So when they go out on a thinking walk, small children do different things. They, for instance, go with different leaf templates and look for such leaves. They have a workbook too, which has those templates, which they cut out. They cut out these templates and actually take them and look for such plant. And as you can see, these are very commonly found plants as well. This is the geranium, the common geranium. This is the chrysanthemum or the marigold kind of a thing. So it's all very commonly found plants, so they will be easily finding those leaves, right? And then if they are common plants, they pluck the leaves and they have a place where they can actually paste it. They pluck it and come and paste it in the worksheet, right? Spot the plant where they...
This happens on field.
On the field, yeah, of course. They go out where they... It may not be any forest like that. It can be a small little park which you found, or maybe just the footpath where there is little flora. That's what they do. Right? There are lots of such activities. One, for instance, is where it's a seed bank. It's called the mini seed bank. There's a particular way of collecting seeds, storing it, bringing it to the seed bank, and depositing it in the seed bank. They are introduced to that entire process of seed banking, right? And this is maintained by the teacher. So the children bring it in a particular way. They fold a paper in a particular way, process the seeds in a particular way, and bring it to the teacher, right? Which the teacher deposits here and then explains why am I doing this, why is there silica gel, why is a coloring agent silica gel, and all of that is explained to the children, right? As an extension, we have tied up with 3 botanical gardens in India. One is the National Botanical Research Institute in Lucknow. The other is in Orissa, Bhubaneswar. The third one is in Kerala. These are the three different regions in India. If the teacher and the child thinks that this is a rare species and I have found a nice seed which I can describe and explain in the particular format expected by the seed bank, they do all of that and submit it to one of the seed banks in these three institutions. They get an acknowledgement as well, which they can present. The teacher and the child can preserve that. So those kind of things happen in this project, right? There's another one where they actually create this herbaria. They preserve plant data. They have these presses. They use these presses and create something like this. Like they create a plant herbarium, right? And they can of course describe the whole thing as well, right? So this is another activity. There is one activity very interesting, my favorite activity, which is around the sunflower seeds. So we give them a packet of sunflower seeds. Why sunflower is because it comes in different sizes, right? Each sunflower seed is of a different size, typically, right? So we also give them a magnifier lens. Right? This kind of a magnifier lens. So they take 15 seeds. Every time I open this staple is black. Right? So they take 15 seeds, which are of different sizes, and they use this lens and measure each seed. They code each seed in the first place. They say S1, S2, S3. They identify each seed and actually measure it using this. They keep it on a plane surface and actually measure. When you see this, you can measure it. For instance, this is 0.8 centimeter. This one is 0.8 centimeter. This could be 0.6, 1.1, 1.2. So I pick up 15 and measure each one of them and put them in a table, right? And then they are given instructions in their workbook to fold old newspaper in a particular way.
Make the pots.
Right here, they can fold old newspaper in a particular way and create pots like this. Pots are made out of newspaper. They can stack one to the next. The newspaper, they take a felt marker and write S1, S2, S3, S4 up to 15. Take the S1 seed, they have measured it. They plant in S1, S2, S3. They stack up 15 like this and then plant S1 to S15. Right? And then keep watering it every day with equal amounts of water into each one of them. And keep observing every day. They germinate. Right? They record the germination data. Which seed germinated when? They record all of that. Then growth over a period, like every day how much did each plant grow, they record the data.
It's a newspaper.
Newspaper, yeah.
But you put a sand, soil.
Soil, yeah. The soil. We fill it with soil and
And
plant.
stand the string of the
Yes,
soil.
yes. Because it's only moss we put. It's not sand.
But
Why
when
hold the moist?
Moss.
Moss.
Moss is like
Yeah.
what do you
Green, the
You see
green
the
thing.
coconut
Exactly.
tree, the
The
coconut tree,
yeah, or the coir pit,
the coir pit.
and
moss
moss.
อะค่ะไอ้เขียวๆที่มัน
when children watering it,
It's only small cup of water.
You just need few
Nothing
drops
happens
of water in
for
each
15
cup.
days. Nothing happens to the pot for 15 days.
It's a very normal thing called jiffy pots to to germinate the seeds.
Yes.
So if
Something
you go into this plantation
Nurseries,
size
yeah.
nurseries and all, you'll find it.
Right.
This is a cheap way.
Yeah,
Yeah,
exactly.
and also
That's
biodegradable, right?
So
They don't
we
use
have
plastic.
these 15 plants, their growth data, everything recorded. So there is data gathered. Now there is analysis which the teacher asks them to do. One is, which one do you think, firstly, even before that, they plot all these data what they have got into bar graphs. So there is a bar graph that they do. Firstly, size of the seed, it's like this, a bell curve. Then the germination data also is a bell curve. The growth over a particular day is also a bell curve. Then the teacher in the class asks 10 children, what's your height? They plots that, it's also a bell curve. Then what was your last test score? That's also a bell curve. Then she says there are lots of things in life which fall into this bell curve. Hence it is called a normal distribution. So the normal distribution is as a principle is taught to them. Then she says lots of things in life are normal curves. You should be aware of that. She also brings a little tinge of philosophy, right? And then after that, she asks them to do some analysis. Which one germinated first? Was it the big seed or the small seed? You have the data. Now you tell me which one germinated first, right? Some of the children, because this is done in groups, they have data from multiple teams, right? First, let's say one team said the small seed germinated first from their data. Whereas the other team may say the big seed germinated first because that's what their data suggested. Then there is a corollary activity. There's a opaque packet of 100 candies in it of different colors. And the children are asked to estimate the number of orange candies in it by picking up 5 candies from it without seeing. So there is a packet, they will have to blindfold it, they pick up 5 candies and they will have to estimate whatever, orange or red number of candies. So if they find 2 out of the 5 candies as orange, then their guess would be that 40% of it is orange, right? Then the teacher says, now you take one more time. So when they take one more time, let's say there was just 1. So now they have 10 candies and 3 out of them are orange. So it's 30%. So then actually they do 5 or 6 times and then actually give the real number of orange candies. So as the sample size increases, the data gets more and more accurate, right? So that is what they related to this. Now you said small seed germinated first, and that guy is saying big seed germinated first. Now let us gather the data of the entire school, the various teams which conducted this experiment over a period, right? So with that data, let's try and conclude which one germinated first. Then they go on. We have a website for this where multiple schools have uploaded their data. So they go to that schools, that data, and then they try and make a hypothesis of which one germinated first, small or big. Unfortunately, there is no correlation. There is no correlation of big or small for germination. So that is what they conclude. End of the day, there is no correlation because each time it is showing up different things. So that is the activity, right? So if you look at this activity, whatever they are performing, 2 things very important here. One is that it is cross-curricular. It's talking about science, which is plant science. There is a little bit of art and craft, origami kind of stuff.
But
there is
the
math.
cross-curriculum is something very difficult. Actually, the key is the teacher.
Yeah.
True. But if the teacher has these kind of resources made available to her as tools, her job is so much more easier. She has a
Your
starting point.
tools and curriculum is geared towards the Indian curriculums, right?
I'll show you. What we have done is this. We have taken each of these activities, let's say whatever grade, let's say this is grade 5, alright? So there are these activities that they do which map to the curriculum.
Of different regions.
Here we have mapped to the National Curriculum Framework of India, right? We have the curriculum and we map it to that. See, theme is plants, sub-theme is growing plants. So the key concepts or issues. This is from the curriculum. We have mapped it to the curriculum. This is one page what we need to change for Thailand, let's say.
Yeah. So map it
How
to
does it map to the Thai curriculum? We anyway know the curriculum now very well.
Map for us.
Yeah? So that is the mapping we'll have to do. Right? So one is cross-curricular, right? We have plant science, then maths, then art and design, a tinge of philosophy and all of that.
What kind of teachers that you need to hire too?
I'll give you the job description and I'll come to Thailand, we'll hire together.
Again, how do you combine? I can see the music notes in there.
Sorry?
I can see the
Music
music
notes, yes.
Yeah, how do you combine the
There's a
music note to the curriculum or to the teaching?
There is, because we had the music note is for Darwin song. There is
Yeah.
a Darwin song which is given to them.
Next,
after the
Yeah. There's a Darwin song.
Yeah.
Mr. Darwin song. This is written by David Haynes, which is available, right? And this is the recommended note by Singastic. This is available there, right? So this is available. Now the children are encouraged to identify the notes and sing it. Those children who are studying music. The other is, try and play it on let's say a keyboard or a piano. So notes are available, you do it in different ways. They're encouraged to do that. So that is why, so there is also something called as a Darwin storybook. So this is to promote literacy, right? Reading habits and all of that. So there is a Darwin storybook. This, this life story of Darwin from whatever.
Anything that related to
1909 to
Darwin.
1982. 1809 to 1882. So the whole thing, from 1817 to 1831, what did Darwin do at the age of 8 to 22, right? And then what did he do? He went on HMS Beagle around the earth, right? Voyage of the Beagle. That's what he did when he was 22 to 27, right? So this actually promotes reading. So there is another cross-curricular thing: reading, art and
Those
design,
are the different
music,
objectives, right?
music. Yeah,
Working
that's why
collaboratively,
made it truly
capturing
cross-curricular,
data,
not just
analyzing data, writing skills.
Yeah. Not just
presenting
scholastic, but
skills.
post-scholastic as well.
All of it.
Post-scholastic activities like music, dance, working in teams, communication skills, presentation skills, all of that.
Decision making.
Yeah.
All
So
of
that is the whole idea of this project. While cross-curricular thing is the first one thing, the other is what are they trying to do here? If you examine this particular activity, one activity, what I explained, sunflower seeds, they have created a setup. They put up their setup. They conducted an experiment. They gathered data. They analyzed data. They presented their data and made conclusions. What is this? This is a proper
Project.
research cycle.
Yeah.
Any research goes through this flow. Create the setup, conduct the experiment, gather data, analyze data, present data, make conclusions. Right? That's exactly what they are doing in grade 6. Right? That's the difference. Right? Research in our minds comes only after you have passed you completed your graduation. Right? So it's not necessary that you should do only then. You have a bent of mind towards research, you promote that from the age of whatever, 12, 13. That's it.
Okay, thank you.